Windows one. So yeah, I'll let you know. But it's like there's a little FN button on the
4
top.
times 9 is 36.
And now if you
6
have
times 1 is 6. 8 times 20 is 160. 9 times 4 is 36. 6 times 8 is 48. 3 times 12 is 36. 7 times 20 is 140. 4 times 8 is 32. 7 times 9 is 63. 8 times 7 is 56. 9 times 4 is 36. 7 times 8 is 56. And 3 times 9 is 27. Alrighty. Good. Now, let's see if we can get the answers to the big. All right. 12 times 13 is 156. 17 times 9 is 323. 19 times 23 is 437. 13 times 62 is 806. 9 times 111 is 999. You remember the 11s rule. All right. 23 times 31 is 713. 32 by 64 is 1,984. 45 by 32 is 1,440. 65 by 82 is 5,330. 43 times 74 is 3,182. 18 by 23 is 414. 44 by 55 is 2,420. 957 is equal to 11 times 87. And 19 times 86 is 1,634. All right then. Who got all of those answers? Orna, did you get everything right? 100% of both columns? Okay, Avery got them all. Ari got a few wrong. I'm going too fast. All right, I'll wait just a little minute and you guys can check your work to see how it's going. All right. Now, if you guys want to practice at home, and I think some of you wrote that you did, you can go ahead and write this out as an answer sheet. And then tomorrow, you'll have forgotten all the details, and you'll be able to treat it like it's brand new problems that you've never seen before. The bigs are hard, says someone. They are indeed. I did them last night and copied down the answer. I didn't want to have to do them in front of all you all. All right then. Can I send a video or a chart on cross multiply because I am confused, and please answer me. I know this class is big, but it seems you're answering the same questions by the same people. I'm sorry if I'm spending too much time on some people's questions, but I bet almost anyone, everyone here would like to see the cross multiplying happen again. And I would too. Let's see if we can do a few of these together on the screen. And the answer to tomorrow or Wednesday is, it should be Wednesday that we get together again at the same time. Okay. Let's do a new share. And let's go to the whiteboard. All right. Let's make the whiteboard nice and big. Okay. Now, 15 times 15. Do it the old way. 5 times 5 is 25. Carry the 2. 5 times 1 is 5. Plus 2 is 7. 1 times 5 is 15. 1 times 5 is 5. And 1 times 1 is 1. Or we could go 1 times 15. 5, 12, 2. Now, we do it this way. We do it the cross multiply way. 15 times 15. 5 times 5 is 25. We write down the 5 and carry the 2. 1 times 1 is 1. Good. 1 times 5 is 5. 5 times 1 is 5. So in the middle, we've got 5 plus 5 plus 2. That is 12. This 12 is really a 1, so we carry the 1. 1 plus 1 is 2. 2, 5. Same answer, different method. I'm going to teach you guys a math word. The word is algorithm. Algorithm. We'll see that. You'll see it a lot in computer programming and so on. And what it means is it's a method of solving things. Let's clear this off and do something a little different. 24 times 15. Remember we said we were going to do magical mathematics? Well, here's a completely different way of doing it. Number 2, Squeaker, Orna, would you please stop doing that? It's on the system for everybody else. All right. 24 times 15, the old way. 2 times 4 is 20. Carry the 2. 5 times 2 plus the 2. 5 times 2 is 10 plus the 2 we carried is 12. 1 times 24. That was pretty easy. A 0, a 6, and a 3. Now, we'll do the outsides, the ones column. 5 times 4 is 20. We put a 0 here and we carry the 2. We'll leave it over here for ourselves. 2 times 1 is 2. 1 times 4 is 4. 2 times 5 is 10. That winds up being a 4, a 10, and a 2, which is really a 16. 0 carried down, 16 carried down, but remember the 16 is really a 100, so we add it to the 2. 316 equals 316. Now is a good time for everybody to go to their participants panel and let me know by raising your hand. I'm going to lower all hands first. Lower all hands. And now let me know if you like this. If you like this, raise your hand. If you like this, raise your hand. Wow, we got a whole lot of people liking this way of doing multiplication. We got 38 out of 155. All right, 36. Is that how many it is? All right. If you want to vote on this, now is the time to do it. 34 divided by 157. We are going to find the percentage of people who prefer like this method. All right, 34 divided by 157. I'll do this division problem this way. We're going to be down in the decimal area. So what do we think we're going to do? Let's try a 2. 2 times 7 is 14, carry the 1, 10, 11, carry the 1. 314 is less than 340. So 10 minus 4 is 6, 3 minus 1 is 2. And then we carry down the 0. 260. Well, we know it's got to be smaller than 2, and the only number that's smaller than 2 is 1. 157. 3. 10 minus 7 is 3. This is now a 5, so this is a 0. 103 out of 57. So I'm going to say 0.21 and 2/3%. Okay, a little bit more than 1 out of 5 people like this way a lot. So I'm glad that you did. Okay, let's go back to practicing our 70s, because you can't learn anything too thoroughly. You want to learn it as well as you can until you can do it in your sleep. 7 times 1. Okay, that is the wrong screen share. Okay, let's do it this way. We're going to write it in a different fashion. We're going to write it as columns. 7 times 1 equals 7. You guys can write this down with me. 7 times 2 equals 14. 7 times 3 equals 21. 7 times 4 equals 28. 7 times 5 equals 35. 7 times 6 equals 42. 7 times 7 equals 49. 7 times 8 equals 56. 7 times 9 equals 63. 7 times 10 equals 70. 7 times 11 equals 77. 7 times 12 equals 84. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84. Okay, here's something you can do to amaze and astonish your teachers and your classmates. Do the times 7s backwards. 84, 77, 70, 63, 56, 49, 42, 35, 28, 21, 14, 7. All right. Now, let's clear this, and I'm going to show you another method to multiply really fast. It's not fast at first because you're still learning it, but after you learn it, it's pretty darn good. So, it is called the FOIL method. Now, you're going to hear this word FOIL as you go along in mathematics a lot. It also works in calculus, and it works in algebra, and it works in statistics. It's amazing that this one little sneaky trick works for so many different ways. And you're probably wondering what it stands for. F is first. O is outer. I is inner. And L is last. First, outer, inner, last. To Madeline and everyone else who wants to know when the class ends, it ends at 4:30. It's a 1-hour class. So I have a little problem. Let's say this problem is 43 times 21. So the first thing we do is the firsts. What is 4 times 1? Well, it's 4. Except that I put this little arch in the wrong place. It's the first. 4 times 2 is obviously 8, but it's not really a 4 and a 2. It's really a 40 and a 20. But let's just write it as an 8. Then it's outer. Outer means the first one and the last one. 4 times 1 is 4. Inner is 3 times 2 is a 6. And 4 times 1 is a 4. First, outer, inner, last. First digit in each of these. Outer is these. Inner is these. And last is these. Okay. Somebody says it ends at 6:30. I forgot that we're in all 4 time zones in the United States: Eastern, Central, Mountain, which is where I am, and Pacific. So now, writing the numbers like this doesn't really give us any clue as to what it's supposed to be. So our inner numbers, 4 and a 6 equals a 10. Our 8 is our first one, so we write that down in the 100s place. Then we've got 6 plus 4 is 10. And our last is 4. Now, this is really in the 100s place, so it's 904 is our answer. All right then, let's clear that. And we'll go back to number families. So I will give you guys a number family, and you guys will fill it in. $625, Okay. 9 and 9, someone has answered for 81. 81 is equal to 9 times 9 equals 81. 625. Who thinks they have an answer for this one? 2525. That is very right. While we're at it, there's way more than just one way to get 625. 625 is also equal to 5 times 125. 36. What is 36? What is a good example? 6 times 6. There we go. This is the equal, this is the equal. What about division? What happens if we divide 81 by 9? We get 9. What happens if we divide 625 by 25? We get 25. What happens if we divide 36 by 6? We get 6. What happens if we divide 625 by 125? We get 5. All right. We'll do some more. 13. What is a number family for 13? What is a number family for 13? 1 and 13 is the answer. The only numbers you can multiply to get a 13 are the number 1 and the number 13. 1 times 13 equals 13. 13 times 1 equals 13. Now, can someone tell me what that kind of number is? The number itself, time and 1 are the only ways to get that number. 13 is a good example. What numbers are those? Prime. Prime, say some other people. Why are they called prime? Oh, because mathematicians really like these numbers. They're really good friends with prime numbers. What are some other prime numbers? 1, 2, 3, 5. 6 doesn't work because you can divide it by 2. 7 works. It's only 7. 8, nope. You can get 8's lots of ways. 1 and 8, 2 and 4, 4 and 2. 8 doesn't work. 9, that looks like it might work. No, it doesn't work. 3 times 3 is 9. 3 is a prime. What about 10? 10 is 2 times 5, 11. What can we do with an 11? An 11 is a prime number. 12 divides by 2, 13. 13. Somebody wrote that down? 14, no, it's even. 15, no, it's 3 times 5. 16, no, it's 4 times 4. 17. 17. What divides into 17? 17 and 1, that's what divides into 17. 18, even number, 3 times 6, lots of ways to get there. What about 19? 19, is 19 prime? Give me a yes or no. 1 and 19, it is prime, yes. 19. 20, even numbers. 21, that's a possibility. Uh-oh, 3 times 7 is 21. 22 is even. 23. 24, can't be done. 25, 5 times 5. 26, 2 times 13. 27, nope. 28, no. 29, yes. Nothing divides into 29 very well. 30, even number. But 31, wow. All right, there's all kinds of examples of prime numbers. What's the largest prime in the world? Do we ever run out of primes? Well, that's a question mathematicians ask themselves often. The answer is no. There's an infinite number of primes. Infinite number of primes. Okay. Now, we were doing number families. Let's see now. 121. While we're on that one, let's do this one as well. What are the factors of 121? 11 times 11. Remember the 11's rule? You just double your digits, but our digit is an 11. So if we put an 11 in the ones place, it leans over into the tens place. If we double our 10 digit, it leans over into the 100s. 121. Okay, 132, it's right next to 121. What are the factors? 12 and 11. 12 and 11 are the answers. $54, what are the factors? What do you multiply by what to get a 54? Waiting. 9 times 6. Yep, that's the one. 54 is 9 times 6. All right. Let's go back to filling in our well-known multiplication table. Oh, that's not going to do it. Okay. That didn't work last time. Let's go back to the whiteboard. Okay. All right. We are screen sharing. Oops. Wow, this is very strange, isn't it? I haven't ever seen it do that before. Let's do this. Let us take one of these problems and do our new methods. 17 by 19. What do we know about 17 and 19? They're both prime. Okay. And we want to multiply 17 by 19. 17 by 19 using the cross multiplication method. Okay. 1 times 1 is going to be 1. 9 times 7 is going to be 63, and we'll write it way over here. Our inner numbers, 1 times 7 and 1 times 9. We have to add our 7 and our 9 to get our middle digit. Now, 7 plus 9 is 16. But we had the 6 over here, which is really a 6, which needs to be added to the tens column. And the 3 is our last digit. So 3, 16 plus 6 is 22. And we carry that up to here. And we get 323, just the way it was the last time. There we go. 323 is 17 by 19. Okay. Now, is everybody seeing me? If you're seeing me, say so. We got one hand. Sir, I see you. Yes, yes, yes. It looks like everybody is seeing me. Okay. So we're going to drill a little bit. We're going to drill a little bit until the end of class, which is 5 minutes from now. Let's do the 8's times tables. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96. That's the 8's times tables. Now let's do the 7's times tables. 7, 14, 21, 28, 35, 42, 49, 56, 64, 63, 70, 77, 84. 7 times 12 is 84. There you go. All right. Multiplication. What an interesting thing to do. There's so many ways to accomplish multiplication. We have the regular classroom method that we've already used for a long time. We have the cross multiplication method, and we have the FOIL method. Everybody write down the 4 words that FOIL stands for. F-O-I-L. First, FOIL, outer, inner, last. That's right. First, outer, inner, last. Anybody else want to write in an answer? First, outer, inner, last. That's how we do it. Someone give me a problem. 2 digits by 2 digits. 2 digits by 2 digits. Somebody give me a problem. 70 by 34. The old way, 4 times 0, 0. 4 times 7, 28. Which is really 280. 3, we carry down the 0. 3 times 0 is 0. 3 times 7 is 21. 2,380. By the cross multiplication method, 7, 0, 3, 4. We do the ones column. 4 times 0 is 0. We do the tens column. It's a 21. Now, we have to do the 2 in the middle. 3 times 0 is 0, and 7 times 4 is 28. But remember, we have to carry that number over into the 100s column. So the answer is 0, 8, 23. It worked again. Let's try it the FOIL way. And it's easier if we write this one horizontally. 70 times 34. So what is first? Our firsts are 7 and 3, which is 21. Our outers are 7 and 4, which is 28. Our inners are 0 and 3, which is 0. And our last is 0 times 4. Okay, so what does that give us? We add the 0 to the 0 and we get 0. We add the 2, 8, and we get 8 here and carry the 2. And the 21 plus the 2 is the 2,380. They all work. They all give us an answer. And my friends, I'm sorry to tell you that our class is over. It's already half past 4:30 or 6:30 for some. So goodbye. It was nice having you here. Goodbye. Moderator, you can end the class whenever you like. That's right. Bye-bye. Everybody needs to sign out. We need to have the internet space back. Thank you all for being here. I hope you enjoyed the class. I hope you enjoyed something new and interesting. It's new and confusing, and you may have to practice a lot. But you guys are all way past ordinary multiplication now, and the times tables, you'll have to practice them again and again, or you'll forget. But you're going to find that eventually they're going to stick in your brain. Somebody said, I really love this class. Well, thank you. I really appreciate hearing that. Math is fun if you want it to be. Everybody has to sign out. Thank you. Me 3, me 2. All righty.